Hi, and welcome to this lecture on functions. In this lecture, we are going to learn about what functions are, how to use them, when to use them, arguments, doc strings or document strings, and some common errors commonly associated with functions. Okay, let's open up the script editor and get started. In your viewport, press and hold the spacebar, and then click Panels, Panel, and then 5 up from the bottom, go down to Script Editor. Okay, and then we can clean out our output window with the cross and highlighted top box icon. And then within history, make sure that you have line numbers and errors ticked on and show stack trace ticked on. Okay, so what are functions? Well, functions in Python are a block of code that perform a specific task. They allow us to break down a large program into smaller, more manageable chunks, and a function takes input if required, performs some computations on it, and then returns the output if required. In Python, you can define a function using the def keyword, okay, def, so followed by the function name and parentheses. The input, if required, is specified within the parentheses, and the body of the function is indented below within it. So let's look at some examples and how to use them. Here is an example, a simple function that adds two numbers together and then will return us the results. So let's type in, let's call this function just simply add numbers. Okay, open up parentheses. Okay, and we'll type in the two arguments A and B. And then our result, okay, will equal A plus B. Nice and simple. Okay, and we will return the result. This function is just called add numbers. It breaks down, or it takes two positional arguments, okay, which are A and B. Okay, it performs the computation, which is A plus B with our two operands, the operator, the plus, okay, and assigns the output of that to result, okay, and then returns us that result back. Okay, so for example, to call this function and get those get the results, we would type in this. So my sum. Okay, and we will say my sum equals add numbers. Okay, and then we'll just pass two numbers and we'll go 5 and 7. There we go. So now if we print, so we've highlighted all, and so I pressed Control and Enter. So now if we just print my underscore sum, and we highlight that and then press Control and Enter, we get 12. So yep, the result of 5 plus 7. Okay, pretty straightforward. I hope you're following so far. So we've called add numbers, okay, with the function, and we have done essentially A equals 5 and B equals 7 within our function. And this is then calculated. So this is what we're passing here. 5 goes to A and 7 goes to B with the basically what we're looking at here. Let's have a look. How can we, let's try and break this quickly. So what we can do is we can quite simply, we can see here that add numbers takes in two arguments. So if we add in a third, what's going to happen? We get a type error. Okay. Add numbers takes two positional arguments, but 3 were given. Okay, simple. So you've kind of, again, been given exactly what's happened. It's made it very obvious for you. It's told you the function. It's told you what it takes. Okay, but it's told you what you've given it. So it takes two positional arguments. You've given it 3. What you need to do is say, oh yeah, I've done 3, take away 1, and then it'll be working. Easy. All right, brilliant. So let's have a quick look at global variables, which again, don't use too much because I work in quite large libraries, so everything is kept specifically within functionality of either functions, classes, very, I suppose very, well, not completely rarely. You will have global variables or variables that are essentially may remain consistent, like file locations. But even then, you probably want those to be set dynamically or with a little bit more logic. But here we go. So a global variable. Let's clear out our output window. So variables, so a global variable is something that is created outside of a function. So let's have a little look. So something created outside a function, just here, it's within the window, it's within the top layer of Python. So, okay, and this is known as a global variable because it's outside any function and it is being seen by all functions below it, classes below it. Global variables, they're basically used by everyone. I'm trying to think of the best way to say it, but they're used by everyone, both inside and outside of functions. But they can also be overwritten. So let's just do an example here. So let's do a def and let's do my function. And this isn't going to take any arguments because it doesn't have to. Okay, and we're going to go print. Let's be really cool and go Python, spelled very well. Python is X. So, and we'll just type in Python. Function. Okay, so now let's initiate all of this. So we've got our global variable. Okay, we'll remove, okay, that will give us an error. And then we'll just call our function. So we've initiated our function, which has a print statement, which says Python is, and then whatever it sees as X. So yeah, we got Python is awesome. So we've picked up our global variable as X, okay, of X, and it's being used within our function. But this can be overwritten. This only works essentially while there isn't, okay, an X defined within our variable. So we could rewrite this as great within the function, rerun everything, okay, highlight the whole screen, Control A, Control Enter. And now you see our global variable has been overwritten essentially within our function. So if we call our function, we are always going to get Python is great. But outside of our function, if we print X, we get awesome. So, okay, within a function, our variables, okay, only essentially are initiated within this function. This function holds everything that is indented within this block of code. We can't call X here itself, okay? We have no way to actually access it here, okay, from my function. But what we do have is still X initiated at the global level. So even though X is being overwritten within this function, we are still able to get the global X because we've not overwritten it, okay, at the base level. So awesome. So again, highlighting, pressing enter. So another way we could do this, so we could just put an X here. And we could just say, great. So let's remove that just so I don't get confusing. See, we've called it, we've got Python is great, because again, what we're passing here is being assigned to our X variable within our function, meaning that our global X isn't being used here. It's being overwritten within our function, okay, and is then being called. That's just a little sneak peek of global functions anyway. Okay, let's talk about when to use functions. So, as often as you can. Let's talk about an example. For the other day, I was asked to make the button material colors of a prop 10% less dark for the animators by the animation lead, essentially, on that project. These materials are only seen in-house for review, and they're going to be seen by the client in review. So it doesn't matter, essentially, how much I change the materials or assign to them at this point. They've just got placeholders at the minute. Although the issue is that there are over 100 buttons. Okay, they all have an individual material that is assigned to them. And so again, you have to think, well, okay, how long is this going to take? Okay, and what's the best way to do this? So I wrote a little script to do it, because they were uniquely assigned shaders, as I already said, on each item and each mesh, and they needed to be, and essentially those shaders still needed to be the same shaders for pipeline purposes, But to select each one of them and to change their brightness manually, it might have easily been, 10 to 20 minutes work, okay? But I spent about 20 seconds writing this script using the system we're going to be diving into later. And that saved me a massive headache. You've got to imagine, okay, sometimes is it better to write the script or to do something manually? I'm going to go with 95+% of the time it's better to write a script, okay, and try and store it somewhere for future use. So let's say, I was in the shading editor, and let's see, the code I wrote was materials equals, so list comprehension. Okay, DAG, should show you what I was importing for it. So from modules, import, now what is it? So it's from modules, nodal, okay, import DAG, node, yes, DAG. Okay, I'm even too lazy that I don't want to type in the extra 5 characters, okay? I want to use this namespace to hold DAG. So this is our DAG node, okay? And we're going to talk about this later on what it does. DAG stands for Direct Acyclic Graph, okay, which again, we will talk about later on. But so from my module, so I've got a folder called modules, okay? Within that folder, I've got another folder called nodal. And within that folder, nodal, I've got my DAG node, okay? I've got that functionality or that class called DAG node. So, and then I'm importing it with the namespace of DAG. This doesn't really matter as long as it increases readability or doesn't affect negatively readability. Okay, we put this as whatever's easiest. So let's go I for I in, so Maya list selected equals 1. Okay. So again, this is, some people you'll see this written within Maya as Maya commands or like this. So you'll see this written as commands. But again, I don't see the point in this because I'm not sure it increases readability. It just makes a lot more things to look at. Whereas M dot is kind of always now known as Maya, so you don't really need to look at it. But what we can do is go from Maya, okay. Import commands as M. Again, it makes it a little bit easier for our reading, okay? So if this essentially says list, okay, this is the list functionality within a Maya. So we're going Maya, okay, accessing the Maya module, okay? And we are going Maya list, and then my options for the list are everything that I've selected in the screen. So I literally just selected all of those materials, and then I've got them stored, okay, within that window. Okay, so I've opened up the rig, opened up the scene, gone into the materials editor or the shader editor, and I just literally opened up and just selected all the materials. And so now I'm going to cycle through those materials and go for material and materials. Okay, material dot attributes, okay, which we talked about again, or you've seen in the introduction video. Material, and then I'm going to access its attributes, and then I'm going to access the attribute color.r. Then I'm going to say set that color to the value of material dot a dot attributes, okay, to dot color dot r and get. Now, why am I doing this? Well, I don't know exactly what these settings are, so I want to get the what the material color is first, and now I want to times it by 1.1. All right, now we've got RGB. So these are color R, so it's essentially RGB, that's that setting. In the materials, again, we're going to go through this later. I'm just giving you an example here specifically for purposes of when to use functions, or when to use functionality like this, okay? Because it's better to write everything into a function, and we're just going to get to that in a minute. So you see, okay, all I had to do then was select all I've already had my material selected. So I've run this in the scene. I've had my material selected. Also, I would have imported my modules and my nodal section, DAG node first. I would have then run this after selecting my materials, and then all I've got to do again is click and run this, making all of my items appear 10% brighter. Simple as that. Not difficult, not hard. It took me a few minutes. And it's just, again, it's a way of doing things in a way that you can now reuse the code. Initially, I saved this out into code snippets, and then when I found some time at the end of the day, what I did was I wrote this into a function. But that was essentially only really because what happened was about an hour later, after a few animators had been working in it, the animation lead came back to me and said, actually, can we go 10% brighter? Which, if I'd done this manually, would have made me cry. So luckily I had this code and the scene was still open in another window. So I just quickly opened up the scene again. Just opened up the window again. Okay. And then ran the script again and just checked. And I gave them the call. And even on the call, they said, actually, no, maybe another 10%. And I was like, click. They kind of know that they know that I would have written a script for this. So they just said, yep, can you just do another 10%? And yeah, did it. And yeah, they said, okay, that's perfect. Again, if I'd have called them up after another 20 minutes of clicking on all of them and then manually making them all 10% brighter, it would have been a nightmare. I would have had to then call them up and then say, okay, I'll call you back in 20 minutes, which again is wasting my time. It's wasting their time. It's not things I want to spend my life doing. I don't want to spend my life clicking and doing silly manual tasks. I want to make my life easier. I want to make my life better. And I don't make my life better by wasting time doing jobs, menial kind of jobs that I know I can automate. And you shouldn't either, because you're better than that. Okay, we all are. So the next step was then, okay, after that went out, was just to save this function. Okay, and I called it change color intensity, I believe. And I added it to my materials module. Okay, so this little function in the space of 5 minutes work, it saved me probably about an hour's plus work of annoying manual labor. It was pretty simple. And I could probably explain to you I got some default arguments that I also put for this. So let's have a little look. Okay, so I made this into a function and we're going to call this, okay, define change color in intensity. Okay, now this takes a value, which I'm not going to set as a default. I'm just going to keep this as a positional argument. And then I'm going to have materials. And I'm going to put this as a keyword argument. But then I'm going to give myself a default argument here. And a default argument is essentially something that we write, which allows us to save our time later on. And it allows us to give a default for whatever that variable is going to be. So let's say, for example, we're not expecting to use that variable. Then we might want to put a default of none. Okay, but we do want to give the ability for someone to change it in the future. Okay, we might always have, in 90% of situations, we might always have a certain setting we're going to use. So we change it. So we give it that default because, it just saves you giving the input. But, okay, for this, I put none because essentially I wasn't sure if we were going to have the materials that we're going to pass through to it in a script. And the same with value. Or what we're going to do, or if we're going to be selecting it in the scene. So what I can do there is put a value down here. So essentially whatever value comes through, that'll be the value that this is times by and changes this color. And then what I did was I gave a little doc string, because again, I'm saving this out. Other people might end up using this. So I said takes a value and multiplies the current selected shaders RGB setting. Okay. All right. So got a doc string, so it's nice and easy for someone to talk about. Okay, and again, we're going to talk about doc strings in a minute, so don't worry about these. But okay, what have we got? So we've given our value, we've changed that here, but now we've got materials. We've got a keyword argument here. Okay, and this is set to none. So we're going to make our materials, are going to essentially use materials. We're going to use our one-line conditional statement. If materials is not none, else, my lord, my typing, sorry. Again, if I haven't already said, I'm recording these after a long day of work. Actually, it wasn't too bad. It was a good day of work, but again, I was writing a lot of scripts, so it's my head sometimes It's not brilliant at doing everything again after a long day. Like talking, typing it all at the same time. I'm not brilliant. Sorry about that. I'll try to keep on improving. So what we've done here, we've got our keyword argument. And we can either pass this again, we can either write this into a script, we can pass a load of materials, make them lighter, darker, or we can essentially use this as a script and put it into a button quite easily within the screen and then call it and say, well, yeah, okay, if the materials are passed, okay, then use those materials within the list. But if materials are not passed or if they equal none, because remember, if we pass something as none, let's have a look at our bool. Like we looked at before. What does bool none mean? Bool none means false. So if this is false, then it will go else, and it'll select our scene's usage. Now, okay, we didn't put any error handling in it because I didn't feel it was necessary. This isn't something that someone non-technical within any department is going to be using. This is going to be someone using this that can look through this script in, next to no time and say, yes, okay, this is what it's doing. It is literally takes a value, oh my lord, takes a value and multiplies the current selection shader's RGB setting. And then they can go, oh, yep, okay, so we're getting a scene selection or the past selection. And then it cycles through those materials and it says RGB, it sets them, okay, using the current color times divided by the value. So again, it's being very, very clear, okay, on what we're doing here. Okay, it makes it nice and easy, okay, for what we're doing. Now we can add some checks in, so because this is an object, okay, and it's using our DAG system, which we will be making shortly, we could actually go, well, if material dot exists, actually what we do need to do is what we've not done here is actually check that these materials are DAG nodes. We'll assume that somebody, and we'll assume that they know that. Again, it will provide an error actually for you saying that DAG node is required to access this, because if a string is passed and we try to access a .a using a dot notation, we're actually not going to get anywhere in this, as we talked about in the last lecture. Okay, dot notation allows us to access part of a class, but if it's a string and there isn't a dot notation a, then it'll just error out saying it doesn't exist. So it'll give actually quite clear feedback back to our user, but we'll use a continue. Okay, so, all right, so we've got a little check. So if material doesn't exist, let's say we passed a bunch of materials within our script and one of them has not been found, okay, then we're just going to continue that cycle, not bother to set anything, okay, and it'll go ahead and continue to set the other ones. And then after, we can even return for the user if they need them, because again, you might not, okay, need the returned items, but, you might do, so we'll just return materials. So how do we call this? So let's say we want to do materials equals the name. Okay, we'll call the name of our functionality, change color intensity, and we'll just say we're going to set this 1.1. So now all I would have to do, even then, if I didn't need those materials passed back to me, I would literally just call it without that. I would just, again, select this. Okay, I'll make sure everything had been initiated. I would select all my materials in my scene and then just run this, and it would do it for me. So you see very quickly we've got now one line, which is taking in the functionality of about 10, saving us time. That is the name of the game here. All right, let's go on to talk about arguments. Okay, so we've talked a little bit about the arguments that are being passed in this example. What we're going to do is go into that a little bit further. So, arguments. In Python, there are two commonly used ways to pass arguments to a function: positional arguments and keyword arguments. Positional arguments are arguments that are passed in the order in which they are defined in the function definition. So for example, let's use the following example that we've looked at before and say, look, add numbers, okay, A and B. Now these are two positional arguments here. Now, if you wanted to add A to B, generally if you mixed up the arguments, it wouldn't be too much, which would, again, kind of be a logical error on your part, but it wouldn't matter because, whatever you add to, it would always kind of come up with the same value, essentially. So let's have a little bit of a different example maybe. Okay, let's say that we had a minus. So let's say we had minus numbers, okay? Now, if we had 5 minus 4, then okay, it would give us 1. But if we had 4 minus 5, it would give us -1. So again, the position of these arguments does matter now. and your output then will be reliant on that order. So you do have to remember that you get your positional arguments in order when you're typing them. So let's go minus numbers. Okay, we'll go 5 and 4. Okay, and we get 5 minus 4 equals 1. Great. But remember, switch these up and we go 4 and 9. Let's say you didn't want these to be the other. You wanted this the other way around. You're going to get minus 5, which again will affect you. Okay, depending on what you're writing. Okay, this is going to affect something. All right. I mean, obviously, functionality is being used for a certain purpose. Let's use an example now. Let's say we're working with some objects within the scene. Let's say we have our functionality called add suffix. Okay, and we're going for the, let's say we've got the item and the suffix. Okay, let's say that we're expecting these to be a string. Okay, that could be added into the doc string. But what you're essentially working with here, okay, with add suffix is two items that you can always have is, let's say, sphere. You've got your item you're passing to it, and you want to get your names back and what they should be within the scene. Okay, and let's say, and then we could even just do a couple. We'll take out a little bit more here. We'll add the underscore in as a default as well, so that the suffix doesn't need the underscore. Okay, and we'll go through this and we'll say, well, we're going to be using this 90% of the time, actually. So for geometries, okay, we're using this most of the time to check actually that the modelers are outputting items with the suffix of geo. Okay, now, okay, or making sure that you give them a tool that does this for them. But you don't need to write this every time. What you can do, if you're knowing that 90% of the time you're going to be using the suffix geo, and you can just write that in, okay? Geo, no, or gep. We're going to use geo. And what this will do then is negate the reasoning or negate the point of you adding that second bit of code in. Again, it increases readability for you because now I'm looking at a lot less text. I'm looking at add suffix, sphere, ball, rock. Okay, much easier for me to look at. Again, if you have something like 5 or 6 of these, and a lot of the arguments, like, for an aim constraint, a lot of them are default, like with world up object or world up axis. Your world up axis is generally Y. Maybe you might as well put that as a default argument. This keyword argument is better to be default and just to save you time writing it than it is for you to have to write it every time. So these few seconds you're saving every time are really important. So now look, okay, let's have a look. So we've scanned, okay, I've selected all the items, I press Control and Enter, and we have, okay, initiated our function, and then we've called our function, and we've gone add suffix to sphere, ball, and rock. Nice and easy. So let's talk a little bit now about arguments. Let's clear our top window. In Python, there are two commonly used ways to pass arguments to a function. They are positional arguments, which we've already done with A and B, or, okay, so along with positional arguments, there are keyword arguments. So let's have a look back at our add numbers, which we had a minute ago. Add numbers, we had A and B, sorry. Let's change that, that should be A and B. Could have just changed that there, but oh my lord, this is what happens when you're tired. Do silly things. Okay, so we've got add numbers. So I'm just updating the docs, which are essentially the write-up of this lecture, which I'm going to pass to you after, just so that you can have this all stored. So here we've got our positional arguments. They're just positional, okay, based on the position. Okay, this will essentially dictate the order in which you add, okay, your numbers to it. If you want 5 to be added to 7 or 6, okay, and it had to be in this order, you would add 5, which would be A, and 7 is B. If you were doing a subtraction, maybe that would be a bit more important, because if you had 7 subtract 5 and you want it to be that in order, you have to make sure it's in that order. So again, to call this argument, to call this function, you just type in add numbers, and again, select all, and then okay, enter. Okay, hit Control and Enter. So very straightforward. Okay, and that is a positional argument. Okay. All right. Let's move on. Let's have a little look now at a keyword argument. Yeah, I'm amazed I've not lost my voice this week. Actually, I've been doing so much talking with these tutorials, but yeah, I'm getting used to it. And I'm very sorry again about my diction. I will hopefully get better as we talk through these tutorials. Okay, so keyword arguments. These are arguments that are passed with a keyword and its value. They don't necessarily have to be in order like positional arguments are, but okay, the keywords do have to be named correctly, okay, in some instances. So let's have a little look. Okay, let's have a first example. Let's do def greeting. Okay, we'll open up parentheses and we'll go name, and we'll then go for the message. Okay, we'll add our colon at the end, and then we're just going to go for print. Okay, we're going to add an F string, and then we're going to go with, so message. Okay, no, we don't want to do that. And we'll go with, again, open curly brackets and name, exclamation mark, so we can live on the edge. All right, so to call this function using the keyword arguments, you would pass each argument with its corresponding keyword. Okay, and we would put greeting, okay, name, John, message, hello. So let's highlight all and press Control and Enter. And then look, we get hello, John. Again, remember our F strings we looked at in our string module lecture. If you are unsure about this, maybe just go back and have a look, or even just search the internet and go to W3 Schools. They have a great breakdown of this. But yeah, again, F strings are just, I think, the nicest way to essentially create your strings within Python. It's the most readable way with the least amount of, you don't have to do dot format. Okay, and then open more parentheses and then open more arguments. You can just literally have the argument within the string, within the curly parentheses, within the curly bracket, sorry. Nice and simple. So as we're saying in this example, the name, John, is a keyword argument, okay? It specifies the value of that name and that parameter. The message, hello, okay, is a keyword argument that specifies the value of the message parameter, okay, which again, pass through right over here. You can also mix positional and keyword arguments in the same function and call. So here we've got a positional, again, as long as we're using it in the right position, it'll be fine. And we still get hello, John. Okay, see, it all really comes down to, again, the order that you're passing these to. If you're not going to use the keyword, then you definitely have to use the position, okay? Because that is essentially what Python is going to use in lieu of having the name, okay, message. So we can use, okay, message equals John, and message equals hello, and name equals John. And that doesn't matter because name, okay, has been used. The parameter has been named. Okay, it's given Python something to run on. But let's see what happens if we put, okay, John now without the name. Syntax error. And the positional argument follows keyword. Positional argument follows keyword argument. So what this is saying is we can't actually use a positional argument after a keyword argument. Okay, once you've got these keyword arguments, you can't now put positional arguments. Positional arguments go before keyword arguments. Okay, nice and simple. All right, easy one to fix. Cool. So in this example, John is a positional argument for the name parameter, and the message hello is a keyword argument for the message, okay? Additionally, Python also allows us to use a single asterisk, okay, for the args, and a double asterisk for keywords or keyword arguments. So this, in the function, these definitions are used to accept variables of different numbers of arguments, essentially. So let's have a quick look at what I mean by args, okay? So args is just short for arguments. But okay, let's have a new example. So let's use def And we'll go for add numbers this time. Let's go again for this. We'll do a bit more of an advanced option. So we'll go for some arguments. Okay, so we'll go, I didn't actually hit my key. Don't tell me I have to change my batteries on my keyboard already. Okay, so we've got args. All right, so we've got add numbers, and this is going to take any number of arguments. And the result, okay, equals 0 so far. And we're going to go for number in args. And we're going to go result plus equals number, or numbers. And then we're going to return the result. So go 4 back again. And go return result. So in this example, args will pack all the positional arguments passed into a tuple. So calling, let's have a look, an example of, okay, add numbers, okay, open brackets, 1, 2, 3, 4. So you can have any number we want here because they're going to be essentially wrapped up, as we said, within this args, okay. All right, now this will result in the args, okay, being packed up essentially in a tuple, pretty much in the same way it looks here. Okay, it's 1, 2, 3, 4, 5. Let's have a little look and see how that runs. Oh, actually, we're going to probably define our function. That would help. So again, highlight and then press Control Enter. Now let's try add numbers. Okay, so you see what we've got here. We've got the result of 15. So args has unpacked everything into a tuple, as we said. Okay, and now we're cycling through that tuple. We're going for number in args. So we're going through each one of these numbers. So for 1, for 2, for 3, for 4, for 5, and that's being unpacked into the variable number, which is then being added to result. Okay, and we return the result of 15. Now let's go for keywords. Okay, let's go for keyword arguments being unwrapped here. Let's try a new function. We're going to go with print details. Let's go with this. Okay, so for, we've got a key and a value. And we are then literally just going to unwrap this nice and simply. As we did with the dictionary, which we talk about in a minute. Okay, and then we're going to print using our F string. Okay. Key and value. All right. Cool. So let's print the details. Okay, we're going to print open parentheses name equals John and age equals 25. So, okay, let's initiate our function. So we've defined our function called print details. This accepts some keyword arguments and it's basically unpacking them using this double asterisk. Okay, so for positional, we use single, and for keyword, we use double. Okay, just try and remember that. All right, so this is actually going to unpack our keyword arguments into a dictionary. And it makes sense when you think about it because we could have John, name, age, address, phone number. We could put all of these, and these will come out as a dictionary as name, okay, John, okay, with the keys name, age, address, phone number, with all the values as John, 25, address, and then phone number. So we're going to unpack these as we've just seen. Let's have a look. Let's run. Ooh, name is giving me an error there. Ah, okay, I've just realized, obviously, I could actually call the function again. So sorry, long day. But we've got print details, and then open parentheses, name John, age 25. Very sorry. Such a simple one. Again, long days. Like I said, I mean, this hasn't even been a long day. It's only been about an 8-hour day for me at work, but been writing code all day. So yeah, pretty easy to happen. All right. And there we go. So we've printed name, John, age 25. You can see here. Interesting. So yeah, pretty straightforward. Oh, of course, I printed a print. That's why I've got none at the end. Okay, because it's actually returned us nothing, but we've printed within there. So we're getting nothing returned, which is why we've got that none. Okay, but we're printing within there. Very sorry again, silly mistakes, but these are actually teaching us quite a lot, aren't they? And, well, things that I obviously know how much we're fixing here, but silly mistakes that just show us human psyche and why it's good to write things into code. Because once we've written the code, fix the errors, and then we go through, rewrite the code, fix it, and it's fine. That's what I like, okay? I don't mind. I don't really care making mistakes, like I said, because we fix them. That's the whole thing. And then your code is great. My rigs aren't the best in the world, but they're the most reliable. I could probably say quite easily with all the companies I've been to, they're definitely the most reliable. They're actually, I'd say, pretty much up there with some of the best rigs in the world. But it's mostly, I'd say the win with them is that everyone I've worked for knows they're reliable. I've never held up a production or had issues with my rigs that has held anyone up. I'm pretty much a silent partner on most productions I go to because there's no problem with rigging. And I always joke with when I'm getting interviewed that I'm the person you don't want to hear from in a pipeline. You know, I'm the person that people want to talk to if they want features, but I'm not the person that you want to be calling, because if you're calling me a lot or you're talking to me a lot and you're hearing my name a lot, it means probably something's going wrong. But luckily that doesn't happen with me. You don't have to generally talk to me too much because I'll test everything, I'll run it, and I'll fix these silly errors, which I'll do here. So that's keywords. Anyway, sorry, keywords or keyword arguments. Okay, I'm sorry, I digress. We've got our function we're defining with print details, which is cycling through our keywords, our keywords, which is, let's have a little look actually at this, what this is. So our keywords, we just print keywords, and we'll actually unpack that, and we'll go, you know, what type are you? And look what we've got. Okay, so keywords, which again is being accepted by these double asterisks, and it's being unpacked into the variable quargs, which again, technically you can rewrite as anything. You could write that down as weather. It doesn't make any sense, but you can. Okay, and you see it prints out the same thing. Okay, let's clear that because it just obviously didn't show us any difference. But look, okay, this is a keyword argument. Generally, best practice is to call this a keyword, because generally you call it the keyword argument, but it's a plural, so we say keywords. So keywords is basically what you'll always see this called in pretty much anywhere you go where somebody has written these arguments. If they're not calling it that, I'd probably suggest they call it that because everyone knows it. It's being called that for the reason it's a keyword argument. And then it's also, again, stated because it's a double asterisk. So it's a kind of a best practices kind of thing. But okay, so that's everything. We've got our type there. It's a dictionary. Okay, that's a keyword. Let's do it with a single like we did a minute ago, just to see our positional arguments being unwrapped. So we just have to put these down as positional arguments, not keywords, so we don't put the key names in there. Okay, we'll do args. Again, because it's plural, we've got args, not arg, singular. And we'll have a look at our type. And it's a tuple. So args unwrap to a tuple, keywords unwrap to a dictionary. They're pretty powerful things. You'll see these a lot, so it's worth getting to know them. But okay, as we've said, functions are fundamental to programming in Python and pretty much every language you'll ever go into. They allow you to reuse code, like we showed with the example that where I'd been asked to do something from a head of animation. But they make your programs more modular. They increase readability and they maintain, and they help readability, but they help the maintenance of your code. Okay, it helps me because I can go through, I can update that code, fix it, change it, add functionality to it, and make myself a better programmer. Okay, let's move on now anyway. Okay, let's look at document strings. Okay, in Python, a document string, or a doc string for short, is a string literal that appears in the first statement of a module, class, a function, any of those definitions. The purpose of a docstring is to provide a concise and easy to read description of what a module or what the module, class, or function does, as well as any arguments that it takes and what it returns. So here's an example of a module level docstring. Let's say you've saved out your module. And with that, oh, sorry, here we go. This module is called string.py. All right. The first line of that, the first line of this module, again, this file might be this module. That deal with strings. So now that would be the first part of that file. Again, this means that essentially you can then, as I showed you with the docstrings, we can go import string, and then we could, in theory, go string, okay, underscore doc, and it would give us that information. Okay, so again, it allows you to look through the library and just read the docs of what's going on. So then within that string.py module, we've got a function called reverse string. Let's say reverse string. It takes the argument s, and what it does, it returns s, and then using our indexing, we can just reverse it. Let's just reverse its order here. So we've got beginning to end reverse. Okay. So now, okay, we want actually people to be able to go and find out what this does. So let's have a look. Let's add in another string, or another doc string. So we'll go returns the reverse of the string. So simple as that. Okay, very straightforward. We've kind of got the information it needs at this point. We've got returns the reverse of the string. So what we would do then to get that, we would go from string, what were we going to do? So from string, yeah, we're going to import reverse string. And then we could go reverse string doc, and then that again would give us that information. Okay, very simple. Okay, so within this context, we could even just go like this for the moment. Syntax errors. What have we got here? Let's have a little look. Returns. There we go. We want return. Again, simple error. Okay. Kind of told us what was going on there. Okay, it pointed to the S here, but essentially what was wrong was we had the returns S. So pretty much right next to it. So enter. And now what have we got here? Return string doc. So the result of that is that we've got returns the reverse of the string. So again, easy, very easy to go through this. Okay, but let's have a look at an example that we were going to be creating later on. I've just opened up Sublime Text, and what we're doing is here. So I'm showing you that first layer within the module. When I import our dep node here, our dependency node. Okay, what I've got is this first string that says author Nick Hughes. Okay, created. Okay, I've put a little bit of extra information in. I've got dep node functionality. Now, again, when I'm onboarding you, essentially, or working with you, I would have explained, or we would have actually gone through the dep node functionality. So you know that this functionality again is to be called mostly through the class itself. And when you call dep node dot underscore underscore doc, what you're getting you are getting this information here that says a class-based way of calling all information that we need to deal with the Maya base nodes with no object dependency. So, okay, this is giving you all the information that you need of what this is. Okay, I've even given you the information of what you need to pass to create this. We've got a node or a string, and you've got a node type, which is only then used for creating a specific node. Okay, so if you just want to essentially add a dep node, all you do is add the string, the name, or the node. Okay, but if you want to create a new one, you pass a string, and then you also pass the node type, and we will actually create a node for you. And then below, okay, I give you an example of what this gets you. Okay, this is going to give you a dependency. where it passes you the object, dep node, got a node, and then we've got our class-based name. We can use dot notation and go dot rename, okay, to foobar, and then we can even go dot delete, okay, and we'll see that with delete, we're actually then, okay, deleting our object completely. All right, simple. So that's a little example there. By convention, Python uses, so let's talk a bit more about the docstring. So by convention, Python uses a restructured text formatting in docstring. So this allows you for the generation of documentation in various formats. So like you can output these as HTMLs, you can output these in PDFs, but you can also use tools like Sphinx or PyDoc to generate documentation from your docstrings automatically. Now, this is really useful, and we're going to probably talk about this a little bit in a few of the lectures before we get kicked off, because we're going to set this all up, okay? But this is really useful because it's going to take into account a very important factor called the bus factor with your code. As in, if you were hit by a bus, or if you were hit by one tomorrow, could someone easily take your code and make it work? And is it written so that somebody can understand it with these docstrings? Now, I know this would be a sad moment, and I'm not trying to make light of the fact that you are dead, but wouldn't it be worse to think that you have died and all of the work that you have done for the last few years is just lost and wasted? Because then the first thing that someone's going to have to do is then rewrite everything you've ever done and make something new. Now, that is a even bigger sadness, at least if they use what you've made when you've been hit by this bus. You've something's good has come out of it. They're actually using your code. At least you'll be remembered for that. But that at least is one good thing to come out of that. You don't want the last few years to have just been wasted. Oh, and you missed your bus as well. Well, I suppose you've not missed it. It didn't miss you, sadly. It got you right down on there. But okay, sorry, we digress. So, okay, that's a basic reason. Always remember, okay, if somebody tells you about the bus factor, okay, it's not a complicated one. It's basically just that it sounds like. What happens if you're hit by a bus, okay? Does somebody else know what you're doing? And you should really work in a situation where everyone knows what everyone's doing, how they're doing it, and everyone looks at everyone else's code, because they'll make you better. It'll make you a better programmer, okay? Hiding and working in silence and trying not to show people your code just won't help you become the best programmer you're going to be, okay? Never, ever, okay? You want to be around people that are better than you and that are really good programmers, okay? Because they will help make you a better programmer. Simple as that. Okay, so in addition to the module, class, and function docstring, you can always use docstrings and methods for methods and attributes of a class, as well as for modules and packages. Using docstrings to document your code is a best practice in Python. And we'll talk about best practices later, but this will make your code easier to understand, easier to maintain, and especially when working in teams, okay? You're not always, even if you're in a small company, if you do a good job, you should assist that company in becoming a lot bigger. You won't always be a small team, or just one at the worst, okay? You will increase, and you want to be ready for when you suddenly, let's say you're at a small company of 10, and you suddenly get a job for, a series of the new Paw Patrol. Sorry, my daughter just loves Paw Patrol in a minute. That's why that came to mind. Okay, that's so normally 52 episodes of 10 minutes. So there's a lot of assets. There's a lot of management, and you're going to have to onboard 3 or 4 riggers. Okay. Now, the beauty about having everything highly automated is that everyone will be working the same way. But the next problem will be, well, how hard is it to onboard a rigger? Okay, or someone technical that can do this work? Well, is it going to be harder because there's no documentation? You have to explain everything to them with every step of what they have to do. They'll say, do we have a function for this? You're like, oh, I don't know. Let me have a quick look. So you have to then stop what you're doing and go and help them. And then the next rigger comes, oh, we've got a function for this. Oh, I don't know. Let me look. And it's like, well, no, you don't want that situation where you're always being pestered. You want to provide people with a library, with an HTML library that they can search, delete, and then they find, oh, yeah, we've got this delete functionality here. They want to search wave function. They can add a wave deformer to your tail rig, to a mesh, and then have a controller set up automatically. Yeah, and all these things I've got in mind. I try to put everything into a module that just means I can click and add it. Because, again, this is an easy way for me to work and know that when people are adding this functionality to rigs, it's added in the best practice or in the best way that won't break. When people add things manually, it takes longer and it's more likely it'll break. Okay, I can't tell you the amount of contractors' work I have to fix in different companies or I'm even brought in to fix because people have made rigs that they weren't really able to do. They followed a tutorial they didn't really understand. And then I've got to go in and fix it, which most of the time I say, well, I can't fix this because I don't know how it was built. But I could build you one in less time it'll take me to fix it, and it'll work. Now, if I can name all the controllers the same, you might be able to save all the animation. So there are always ways around it. But anyway, okay, I digress. Make sure you write docstrings. And let's move on. So here are some common errors that, when you're starting out, they're likely to occur. But again, don't fret, don't worry. Okay, not using descriptive names. Actually, let's get these in the screen. Sorry. Again, you can download all of these and have a look through them, but not using descriptive names. It's just easier for you. Again, holy hand grenade. Don't name a delete function holy hand grenade. Because like I said, if somebody's in your library, if you've got docstrings, they have to search delete. Well, as far as they know now, you don't have a delete functionality because you tried to call it something funny or that you thought was funny at the time, and now no one else can find it. Sadly, you're in a bit more of a grown-up game now. We can't start naming things after all your favorite Pokemon, which again, trust me, I've worked somewhere where a developer decided to name all the modules within utilities, with all the functionality within utilities after Pokemon. And it was like, oh, it was a really funny thing, and other parts of the studio thought it was funny. But I kind of had to be the person that nobody likes then coming in and saying, well, this isn't really proper. And then it was obviously awkward because that person spent 1.5 years writing this stuff straight out of uni. That's fine. But that's not how it's going to work going forward. Again, because I don't know, I didn't know Pokemon. That's great. You've come out of uni, you're trying to be quirky, that's fine. But it doesn't work when you've got a team of 12 people there, going up to the ages of 50 plus. That are all incredibly good programmers, but they now don't know what functionality is where because you haven't named anything clearly. Okay, I want to know that if I need to delete items or if I need to delete solvers, there are functionalities for this. Okay, so name your functionality clearly. Write the docstrings clearly, and everyone will be much happier with you going forward. So that was using descriptive names. Okay. Not following the dry principle, okay? The don't repeat yourself principle. All right, so if you find yourself repeating the same code in multiple places, consider refactoring it into a smaller function that can be reused, okay? That will help make your code more concise, easier to read, and less error prone. Like we've just said, like I did with the materials functionality, wrote it into a little function. I can use that again. Easy, nice. I don't have to look at that again. I've not been asked to do that specific job before. Again, I've been working for 12 years in our industry, but again, you always get a new random little question, which again, I would have done that manually. If it was one button, yeah, I would have moved the slider down 10%, given it over, fine, done. But when you get suddenly a huge amount of buttons to do, and that's a specific case, write it into functionality. So not specifying default arguments. When defining a function, you can specify default values for some or all of its arguments, okay? If you don't specify default values, you may end up with unexpected behavior when calling the function with different numbers of arguments, okay? Because there'll be positional arguments. So sometimes just better to give default arguments. So using mutable objects as default arguments. Be careful when using mutable objects, such as lists or dictionaries, as default arguments in your functions. If you can modify mutable objects inside the function, those modifications will persist across multiple calls to the function. So to avoid this, you can use immutable objects such as tuples as default arguments, or create a new mutable object inside the function. So not handling errors properly, okay? Always include error handling inside your functions, okay? Or inside your functionality, just to handle unexpected inputs or even expected situations, okay? This can help prevent your program from crashing or returning incorrect results. If somebody's, like we talked about, let's say I've got a tool that, okay, copies one shape of one control over to multiple other controls, the driver-driven mentality. If a user selects just the one control and then they click on the button and wonder why it's not working or what it's meant to do, okay, then maybe we should give them an error that says, this tool only works when you are selecting the controller shape that you would like to copy over to its children. Okay, so you need to select more than one item. Again, this is going to save someone walking up to you asking you what it does, you then having to explain it, okay, rather than them just getting an automated response that tells them what to do and why the function is not working. Again, saving everyone time. not including a docstring. Now, unless this is maybe because the name is so obvious of a function, okay, there are always exceptions in Python. But let's say you have a functionality that says delete all selected items. Now, I'd say that you're probably all right in maybe not putting a docstring in on that, because the name of it is kind of obvious. It tells me what it does. But including a docstring in your function that explains what it does and the arguments it takes if it's a little bit longer and what it returns can help others to understand your code more effectively. Okay, like I said, there's very few cases where I'd say maybe you just don't write any docstrings, because in that example, when someone's new to your code base, your library, once you start getting over 5, 10, 20,000 lines of code, I think my code base is about 120,000 lines now. And a few years ago, I had a massive refactor. I cut it down by about 40 when I started using this system throughout all of my code to cut my code base down. But it's a big system, you know. I build everything using code. So it's a lot to handle. No one's going to be able to pick up my system and just within a few weeks go, oh yeah, I know where everything is. But I know where everything is because I wrote it. But obviously no one else is going to know that, okay? Just because you've written your whole library doesn't mean that somebody else can. So that was not including a docstring. Let's go on to not returning a value. Now, make sure that your function returns a value if it's supposed to. If you forget to include a return statement, the function may not return anything, or it may return an unintended value, okay? So, like we said earlier, like with my materials function, I returned all the materials because maybe you're going to use them going forward. But you may not need those, so you don't need to put anything to be assigned to there. But okay, just make sure that, again, you look on a case-by-case basis of whether you probably should or shouldn't return something. If you think that there might be cases in the future where you should put a return in, just put it in. It's one line. You know, return some of the information back from there. By avoiding some of these common mistakes, you can write cleaner, more maintainable, and more effective functions in Python. So yeah, I think that's pretty much everything I want to talk about. Okay, in this video we have learned about functions, how to use them, when to use them, arguments, docstrings, and common errors. Okay, thank you so much for listening, and I look forward to seeing you on our next video.